So our topic for today is all about ordinary differential equation, order 1, specifically homogeneous equations. So to see this, so consider that m function of x comma y dx plus n function of x comma y dy is equals to 0. So if each term of the equation has a total degree n, where n is a sum of exponents of all the variables in a term, so then the equation is a homogeneous differential of equation of degree n. So here, to solve a homogeneous equation, one may choose to substitute x is equals to dy, and then we have differentiating that, so we will have dx is equivalent to v dy plus y dv. Sorry, that it's supposed to be, yeah, that's correct. So on the other one, we have y is equals to vx, and then taking dy is equal to v dx plus x dv. So you may choose this one or you may choose this one. So in here, an advantage may be gained if m, for an example, if m has fewer terms than n, and x is equals to vy is used. So if m has fewer terms, then xvy should be used. On the other side, same goes for n, has fewer terms and y is equals to vx. The resulting equation becomes a variable separable equation. So for m, when it is less than the function of n, so we will have, we can use that x equals to v times y. And then if n of x comma y is has less than m function of x comma y, we're talking about here terms, has less terms, then use y is equals to vx. So for an example, on this one, by the way, the trick for this is you will know if the given differential equation is homogeneous if each term of the equation has a total degree n. So for an example, on this one, for example, this. So we have quantity x squared y plus y squared x quantity dx plus sx cubed plus y cubed quantity dy is equals to 0. So by inspection, we could see that this function is homogeneous because the degree, so for the first term, so 2, and then the exponent of this is 1. So this one is equivalent to 3. So this one is 2 plus 1. So this one is equivalent also to 3. Then this one has a degree 3. And then this one, also this term, has a degree 3. So we can see that all term is all equal. Therefore, this differential equation is homogeneous. Then for this one, another example is this one. Quantity x squared minus xy plus y squared quantity dx minus quantity xy quantity dy is equals to 0. So the first term has a 2. Then this one is 1 plus 1. So it is equivalent to 2. And this one has a degree 2, this term. Then this one is 1 plus 1. This one and this one, so it has 2. So n is equals to 2. Therefore, it is homogeneous. Then, to see this, let's try example number 1. So we are given that quantity y squared minus xy dx plus x squared dy is equals to 0. As you can see, it is a homogeneous one because the first term has a degree 2, then the second term has a degree 2 also. This one has a degree of 2. Therefore, this is a homogeneous differential equation. So as you can see, uh, n has a fewer terms. So we could say that let's substitute y is equals to vx. Taking the derivative of that, we will have dy is equal to v dx plus x dv. Substituting this one into our problem, so we will have vx quantity squared minus our x, which is times y, our y is equals to vx quantity dx plus x squared quantity our dy, which is equivalent to v dx plus x dv. So I'll substitute. So we will have x dv is equals to 0. Then simplifying further, so we will have v squared x squared quantity minus vx squared quantity dx plus x squared quantity v dx plus x dv is equal to 0. As you can see on our first term, so in our dx, we can say that we can factor x squared out. So we will have x squared quantity v squared minus v dx plus x squared quantity v dx plus x dv is equals to 0. So we could multiply both the first and the second term by 1 over x squared. So multiplying by 1 over x squared. So we will have this v squared minus v dx plus quantity v dx plus x dv is equals to 0. As you can see, uh, this one and this one will cancel out. So we will have v squared dx plus x dv is equal to 0. Then transposing this one to the other side of the equation, so we will have x dv is equal to negative v squared dx. Then dividing both sides, so dividing both sides, I'll just change my ink. So dividing both sides by x and then v squared, then x and then v squared. So as you can see on our left side, x will cancel out. So x will cancel out. And then on our right side, v squared will cancel out. So we will have dv. So v over v squared is equal to dx over x. So integrating both sides of the equation, so using power rule, so we will have first, I'll change our left side into this. So it will become this integral of b raised to negative 2 dv using rules of exponent is equal to integral of dx over x. Integrating our equation, we will have b raised to negative 1 over negative 1 is equal to ln of x plus c. So as you can see, we have negative sign here, sorry. We have negative sign here. So simplifying further, negative 1 will cancel out. So we will have b raised to negative 1 is equal to ln of x plus c. So simplifying further, so we will have 1 over b is equal to ln of x plus c. As you can see, our v is equivalent to what? Our v is equivalent to vx. Sorry, our y is equivalent to vx. So our y is equivalent to vx. And then dividing both sides, solving for b. So we will have x dividing this by x. So this one will cancel out. So b is equal to y over x. As you can see, we have 1 over b here. So we will have 1 over b is equal to x over y. So we will have x over y is equal to ln of x plus c. Multiplying both sides by y. So we will have x is equal to y ln of x plus cy. So that's the answer. Then moving into our second problem, example. So we are given that quantity x plus y dx minus x dy is equals to 0. Um, by inspection, we can see that this problem is a homogeneous equation because it has a degree 1. It has a degree 1 on the second term, and also it has a degree 1. So as you can see, since m has um, many terms, so we will say that y is equals to vx for easy solution. So we will have dy is equivalent to v dx plus x dv. Then substituting this into our problem, so we will have quantity x plus vx quantity dx minus x quantity our dy, which is equivalent to v dx plus x dv is equal to 0. So factoring x on our first term on this side, so we will have x quantity 1 plus v quantity dx minus x quantity v dx plus x dv is equivalent to 0. So multiplying both sides of the equation by 1 over x, as you can see, we will have 1 plus v quantity dx minus quantity v dx plus x dv is equivalent to 0. By inspection, you will see that v dx here and then negative v dx here will cancel out. So we will have 1 dx minus quantity x dv is equals to 0. Then I'll transpose this one to the other side. So we will have x dv is equal to dx. Dividing both sides of the equation by x. So by x. So x will cancel out. Then we will have dx over x is equal to dv. Integrating both sides. So integrating both sides of the equation, we will have ln of x is equal to b plus c. We know that the value of sorry what we know that the value of y is equals to bx. Solving for b, so we will have dividing both sides by x. So we will have x will cancel out on this side. So we will have the value of b is equivalent to y over x. So we will have ln of x is equal to y over x plus c. Multiplying both sides of the equation by x. So we will have x ln x is equal to y plus c times x. So that's the answer. Then moving into our third example. So we are given that x dx plus quantity y dx minus x dy times cosine of y over x equals to 0. So by inspection, as you can see, this part is the complicated one. So this part, sorry. So this part is a complicated one. So uh we will let y is equal to vx. So as you can see, when we let y is equals to vx, so we will have cosine of y over x. So substituting this one to this, so we will have cosine of vx over x. So x will cancel out, so we will have cosine of b. So we will use this one for simplification. When we use x is equals to v times y, then substituting this one into our equation, into this, substituting this one into this, we will have cosine of y over, which is the value x b y. So y will cancel out. So we will have cosine of 1 over b. So it will complicate our problem. So we better use y is equals to bx. I guess I'll choose another ink. Y is equals to bx, and then taking the derivative of that. So we will have b dx plus x dv. So this one is a better choice than the other one for easier calculation. So substituting this to our problem, we will have x dx plus quantity, our y, which is equivalent to bx times dx minus x, and then the value of our dy, which is equivalent to b dx plus x dv, and then quantity cosine of our y over x, so it will become cosine of b is equals to 0 because we let y is equals to vx. And then we will have, so as you can see, factoring x, so we will have x quantity dx dx mm, plus uh, plus b dx minus b dx, transposing negative, so minus b dx minus x dv minus x dv, multiply this by, sorry, I forgot the cosine b. So multiplying this by mm, uh, multiplying this by cosine of b equals to 0. And then, as you can see, b dx will cancel out. And then, sorry, this one is x squared dv. Sorry, this one is x squared dv. So we will have this x dx minus x squared cosine of b, and then is equals to 0. So dividing both sides of the equation by x squared, so by x squared, so on this one x will cancel out, and then this one will cancel out, so we will have dx over x minus cosine of b is equals to 0. So that's dv, sorry, that's dv. So integrating both sides, so we will have integral of dx over x, which is equivalent to ln of x, minus integral of cosine b db, which is equivalent to sine of b, and then is equals to c. We know that the value of y is equals to vx. So solving for b, so we will have x, so x will cancel out, so we will have b is equals to y over x. Substituting this into our equation, we will have ln of x minus sine quantity of y over x is equals to c. That's the answer.